Thank you and good evening. Thanks for holding on until this late. Sorry for going over time. I'll try to finish as soon as I can. Let's see. My job is to talk about the impact on communities, not just the public, but also the engineering communities, like how have they been affected and how have they been impacted, how was their preparedness, and how have they responded, right? And in that response, how did we from New Zealand actually participated? So let's see. As Richard mentioned at the beginning, actually, if you look at the level of knowledge and level of preparedness, that's a mixed bag in Nepal at the moment, because you see enough signs of evidences that they know what earthquakes do and how you better prepare for the earthquakes. But in terms of application of that knowledge, it is a mixed bag, actually. You can see several documents being prepared or haven't been prepared by the from the initiation of the government by engaging the NGO sector like the NZSEE, and there are some reasonably good documents. Actually, I flicked through them and looked at them, and they are comparable to what we do in terms of philosophies. And if you visit some new construction sites, new buildings which have been built just recently following the building code, some good practices become obvious to you. And you see, okay, these people also do know. And it is not to indicate that actually all new constructions are that well thought. Actually, there are mixed bags, but probably the problem, part of the problem is also in implementation, not just the absence of the knowledge or the code, but how to implement that strictly and cruelly, right? So, if you look at some of the other practices, like even after the earthquakes, to get the buildings inspected and before using the building to get engineers' advice, actually we have got evidences that was being done, at least in corporate sector, the corporate buildings and public buildings, that was done definitely. And although not just the government team to placard the building, but also the private structural engineering firms were being engaged to assess the building and give some certifications like that. The only difference perhaps you will notice is the last sentence where the engineer says the building structure is safe for operation. So probably that using that word safe might be something which we would do differently, because you have only assessed the damage and you can only tell or give some advice in relation to how the building was before the earthquake, where it is now, right? You haven't done the building evaluation, so you don't know how safe it is in general sense, right? So if you look at the building tagging exercise, the practices they follow, the typical tagging placards they follow, they are comparable to what we do internationally and internationally comparable practice. However, the problem, as we also faced in Canterbury, was actually the misinterpretation of those building tagging. And that misinterpretation was very, very dominant in public and also in media. The media used to, fuel those misunderstandings and just put in national daily newspapers that, okay, this five-star hotel has been red carded and it needs to be demolished, right? For them, everything red carded had to be demolished. Everything green placarded was safe forever. That was their interpretation, right? So there was a problem. And actually, people understandably were too scared and they were not trusting the buildings. And one of the main reasons was actually the lack of understanding of the behavior of buildings or the seismic design in general. Like they see any minor crack in their non-structural walls or infill walls, and they immediately conclude that, okay, this house is not livable. Right? So that was a big issue, and raising the public awareness was one of the challenges. And we suggested the Urban Development Department to form a video of, like 1 minute or 2 minutes long, where these things are explained with some visual aid, and requesting all television channels to run those clips every hour. those 1-minute clips, so that people get the awareness. And then we try different sorts of things, and you see, like, out of the scare of being afraid, people are still, actually, you will see a lot of people are living in temporary shelters, and many of those, of course, because they don't know yet about how safe or how badly damaged their buildings are, but there is still a substantial proportion who are doing that, like despite their house having minor non-structural cracks, because there simply isn't a formal mechanism which gives that assurance to them, and they are still living, having that dilemma whether they should go in or they should not. And people are trusting more on the divine power rather than on the technology and what they are seeing in front of us. So just praying for the calmness, peace, and safety to God. Right? And in that particular scenario, it was important for us to play like another role of raising public awareness, and that was done through different sorts of forums, and through media, even going to like the public gatherings, interaction programs with the politicians, and answering the questions raised by the public. And it was simply like, okay, because the all earthquake designed or designed for earthquake resistance doesn't mean that even in big earthquakes you don't get any cracks. Now, all those things, actually, somebody with knowledge hadn't said them that confidently, said to them. So having done that, probably I could see some difference, at least in their belief that, okay, look, because the difference between structural system and non-structural elements, and those minor cracks in the infill walls, what do they mean, and their effect on their overall safety. Right? So there were some really unique ways of doing things in Nepal, which you don't find in other countries, not mainly in the developed world. You see, like the search and rescue, those kinds of operation, not defying all the protocols, safety protocols. They're probably getting carried away by heart rather than mind, not using the mind, but just out of emotions. But the end product was actually a large number of people were saved out of those rubbles. So I have the experience back in 1988 earthquake in Nepal, where my hometown was very badly, one of the most badly damaged, and even my house was collapsed. We were teenagers then, and we just went out in groups of young people, and we didn't have any training of USAR, but I remember clearly, like in my own hands, pulling out about a dozen people trapped inside those rubbles. So a lot of people were taken out, but the practice actually is really questionable. Like it puts a lot of the life of those people in danger. Right? Similarly, unique ways of doing things. You see, like the soaring practice for a small statue of God. You see the level of protection there, and for a large number of people who use that city, like that's the protection they get. And there are some really absurd scenes, right? Because that is the practice that goes on. So it's definitely, I leave it for you to judge, like how they are. But in the public sector, like when after the earthquakes, they waited for a week or 10 days before things was starting to calm down. But the second earthquake, the big one, 7.3, dented their confidence quite a lot. But people were forced to come back to normalcy, and in a rush to do that, they just started covering of the damages, whatever they saw, without any technical input, and that is definitely identified as one of the big issues in the coming days, because those are not going to help in the long run. However, there were some examples of doing things more properly, more convincingly, because the repair being done in a way which is technologically more convincing. Right? And one of the issues, actually, you will see that there are many buildings which collapsed, and Jitendra mentioned about 500,000 buildings which needs to be reconstructed, right? So, and those buildings, a lot of those buildings have created a huge amount of debris, and debris clearance is a big issue, and then the government doesn't seem to have any plan or any management plan for that. And you see, like that building itself is a school which accommodates or hosts about 500 students, and if it had been any other day other than Saturday, which is a public holiday there, the casualty figure would have been a lot higher, because this is not the only school. There are many schools like this which underwent the total collapse. And the other thing is actually the demolition capability. Like there are many buildings which are not completely fallen apart, but are there in a very precarious or dangerous situation, and which needs to be demolished as soon as possible for public safety of the neighborhood. And the skill and equipment that the government has is limited. Actually, I was told when I inquired about this is that the Nepal army can handle only up to 3-story houses, and anything beyond that will have to be done by an international expert, and they have requested that expertise and equipment from China and Japan at that stage, and I'm not sure if they extended that list of countries. And you could see a lot of tilted buildings when you drive around in the ring road around Kathmandu Valley. Actually, a lot of buildings, not just because of the structural problems, but because of foundation and soil problems, uneven settlement, not giving proper thought on where to build, and if you build there, actually how deep or how big how your foundation should be designed. And because of that thing, actually, a lot of buildings have been rendered uninhabitable, despite probably moderate or repairable structural damage as such. So in these cases, like when the buildings have not tilted a lot, but only a minor, that has created disruption in the neighborhood harmony. People are blaming each other. The house owners are blaming each other. It's your house which is putting mine in danger, and vice versa, right? So on a different note, actually, you will see those kinds of practices. It's very difficult to distinguish, right, because in terms of power supply there. So not only the public, actually, the public had some problem. There was some impact on public, but even the technical people, the engineers, they had some confusion, and after going through all the experience, they saw that the earthquake was 7.9 magnitude, which was reported by USGS. The intensity was 9 MMI, and people themselves, they felt strong, sustained, and big jolts. That's what their experience tells them, and many experts, including us, actually, when we see the damage in many parts of Kathmandu, actually the damage is surprisingly less, right? Even seemingly weak buildings, because my colleague or our team leader Richard actually tells the earthquake meter. There were some indications of like how big the shaking was there, looking at those very ill-designed and ill-conceptualized structures still standing there, means the level of shaking wasn't that as severe as we think it should be in that level of earthquake, right? So because of that, the confusion has emerged in their mind. Was the shaking indeed small? In fact, actually, it is, in my view, it is different interpretation of the shaking, because people's perception is mainly related to how far or how big the shaking has been, is related to displacement. And the damageability to the structures are mainly related to earth acceleration. And you will see in a slide later, actually, the nature of the soil in Kathmandu Valley was such that it created earthquakes, shakings, which had bigger displacements and modest acceleration, right? And the confusion, engineers' other confusion was on frame versus load-bearing structures. Actually, if you look at collapsed buildings, most of the collapsed buildings were either of those old stone brick masonry houses in mud mortar without use of good cement, and the other category was reinforced concrete structures, which were built 10 to 30 years ago. And that 10 years mark is important, because that's when in all the municipalities in Kathmandu, the use of building design code was made compulsory about 10, 11, 12 years ago, right? Before then, although the design code, building code was written in 1994, it wasn't a part of legislation, right? So those buildings which were haphazardly built without any technical input or engineering input, actually, and the buildings scarily were like 5-story, 6-story buildings with a very small floor area, plinth area, and standing on skinny 9-inch by 9-inch, 200 by 200 mil, even less than 200 by 200 mil columns, which were spaced 6 meters to, in some cases, 8 meters apart. Right, so you can imagine, like, so they were very, very skinny and dangerous. So of course those buildings fell in soft story mode, which we engineering people we know they are supposed to. But there are still some of those buildings remaining in some areas, so their local effect was quite substantial. And well-built load-bearing brick cement structures did not collapse. So that has raised another question, and people were not afraid to ask that question in open forum. Actually, I witnessed a couple of fora where the engineers, the senior engineers, were asking this question, right? And that is mainly due to their limited knowledge of difference between seismically designed and haphazardly constructed RC frame building. Actually, the buildings which were damaged, which collapsed in soft story, were not the properly seismically designed RC frame buildings. And the ground motion characteristics were unique, right? Because these slides you have seen a couple of times before, so I don't spend much time on that. Clearly, you can see that for those very flexible and tall structures which have got longer period in that 2 second or more region, gradually the demand was increasing in that particular range, right? So the demand for those flexible structures was not negligible. It was substantial, whereas for the stiff structures, the load-bearing 1-story, 2-story thick load-bearing buildings with a short period, the ground shaking was probably a little bit more kind, this particular ground shaking, right? So when we look at it, actually, the shaking intensity, however, when you plot against the attenuation relationships that we know, the several attenuation relationships, that one is the ground shaking, the USGS site ground shaking ground data, and it falls into the lower extreme of the attenuation relationship for that magnitude earthquake and that distance. So the shaking, it is obvious for us to say that for that 7.9 magnitude, 75 to 80 kilometers away, the level of acceleration that was witnessed in that ground motion record was unusually small, right? So, and Kathmandu basins, that soft clay deposit, actually must have some role to play in that, because when the ground motion was modified by that soft clay layer, it amplified the long period components and it suppressed or filtered out the short period high frequency components. And what resulted ultimately was the shaking, which had longer period, very strong, slow, big and slow jolts of big displacement cycles, whereas the big ground acceleration was smaller, right? And this was in line with what we observed in some cases in Canterbury earthquakes as well, because I remember looking at some of the buildings in Port Hills where the indicative damage due to high acceleration, the tiles being thrown away, and the boundary walls, properly constructed boundary walls being completely collapsed. There were indications of acceleration being larger, whereas in the soft soil deposits area, there was indication of larger displacement, right? So it is in line with that. Now, coming to New Zealand team's contribution, actually, I was part of the Ministry of Foreign Affairs team for the first 8-9 days, and rest of my team members returned back, and Jitendra and I stayed on, and I continued on helping the Nepali government and the Nepal Engineers Association in doing that capacity building exercise and helping them do the building assessment and making some policies as well. So that was the New Zealand team, which we assessed in those first 8-9 days, a lot of important and strategically important and government buildings. And not only that, we were called upon to counsel the occupiers of those government buildings, the government staff, in many occasions. And we had to do that counsel not only to the general staff, but also to top government officials, explaining their queries. And we were also requested to assess the damage to the hospitals, 3 important hospitals in Kathmandu Valley, and talk to the medical staff, and which we did. Actually, at that time, the 3 main hospitals, or especially 2 of those 3 were the key hospitals, the B hospital and the teaching hospital in Kathmandu. Right, different sorts of damage, and mainly non-structural damage that we witnessed in those structures. And one of the issues there was actually the professionals, they were speaking and even advising outside their area of competence, and it was creating some sort of confusion, and the media would let anyone come in front and say whatever they like, and despite without like verifying their expertise and their area of expertise, and that created a lot of confusion. I saw several so-called senior engineers who couldn't distinguish between confined masonry buildings and reinforced concrete frame buildings, who couldn't distinguish between structural damage and non-structural damage, who couldn't, many engineers, most engineers who couldn't distinguish between repair and retrofit. They had no clue what retrofit was. They were just doing haphazardly, like putting some eye sections wherever they like and calling that a retrofit. Like they didn't even understand that a damage assessment and building evaluation are 2 different things, and a building evaluation is needed before you even have an idea of where your building is at, and a proper policy from the government is needed to direct you to at the level what needs to be achieved after retrofitting, right? So those things needed to be taught to them, and actually we did that through different media, actually several meetings, several presentations to the senior engineers, even talked in the universities and talked about capacity building for next earthquake, which is not a matter of if, it is just a matter of when, given the geological or seismotectonic environment Nepal is situated in. The next big earthquake is just a matter of when. So the long-term planning to build those engineering capabilities where engineers understood those things and applied those in mitigating the hazard was important, and that was one of the part that we did. And shortage of engineers with knowledge and expertise in earthquake engineering was a major issue, and there were many civil engineers with some structural engineering background but not proper earthquake engineering background. So I went to several engineering colleges, and those 3-4 hours long interaction sessions, question answer session, those were done to do those. So those were all the things that we did, and those are the issues in terms of capabilities, in terms of impact to the communities, engineering and non-engineering. But make no mistake, despite all those damages, despite what is undergoing, Nepal is still, its beauty has not been lost. Its beauty is intact. Probably it has added one more dimension to what you would want to look at when in Nepal, but the other parts, the native, the beauty and other the heritage parts are still plenty of those there, and it is still worth visiting if you are contemplating. So no need to cancel those. Thanks.